I'm going to introduce myself, Ken Greer from Saskatoon, Canada. I'll also be asking Dr. Blake Weiseth, who's new with us as of actually tomorrow. So today is just a pinch hitting day. He doesn't get to present, but he does get to answer as many questions as he wants in this session. So a little bit about myself. I grew up on a grain and cattle farm south of the city of Saskatoon, quite close to the U.S.-Canada border. So I'm near Montana and know all about a few things about the cross-border culture, which used to be a bigger thing. It's now a bit of a stressed thing, but that's okay. I came to the University of Saskatchewan, studied soil science, and started the Western Ag Group of Companies now 35 years ago, which is a long time ago. Blake, if you want to turn on your microphone and bring yourself in to introduce yourself, I think that we should take a moment to do that.
Yeah, thanks, Ken. Blake Weiseth here. Just recently started on with Western Ag course as corporate agronomist. I recently finished my PhD from University of Saskatchewan, working under Dr. Jeff Shano, and there's a bit of a connection to the PRS technology, which perhaps Ken will overview shortly. I too am from the southern part of Saskatchewan, southwest corner of the province, not too far north of Havre, Montana. So yeah, thanks for the opportunity to participate today.
Great. Well, I'm going to kick it off and talk on a few slides, just introduction, and then get into the meat and potatoes of the conceptual, I guess, and the real questions behind um, management of soil, right? And this is the soil health hour, but the good question always is, when you're thinking of health of soil, you're always thinking of it, or most farmers are thinking of it from the point of view of how do plants care about it? Not necessarily how I can measure it, but what do plants think of the soil? And we measure that all the time with things like yield and greenness and just like these beautiful Palouse hills. So I'm going to start through, talk a little bit about what is a plant root simulator technology, and then contrast that to conventional soil testing and take you through how it is being used, well, right in your own area, just, about 35 blocks north of Dave's house, maybe not even 35. I don't know how big Moscow is, but it's not far. It's definitely walking distance for Huggins from his house to our lab in Moscow, Idaho. So just checking in here and wanting to make sure that all my animations are working. The plant root simulator technology is based on probes and these anion and cation probes, which are use a special membrane. They're not large. They look about this big. If I'm holding it up to the camera so that I don't get it fused out. There we go. So they're about a 6-inch long probe that has a membrane inside, and that membrane absorbs um, either anions like nitrate, phosphate, sulfate, borate, or cations like potassium, calcium, magnesium, and ammonium. So we can absorb the nutrients from the soil directly to these resin membranes, and in that way simulate what the plant root sees. So that is the reason for the name, Plant Root Simulator, PRS for short, because many people can't say Plant Root Simulator with good diction. I don't know. It was a good thing to shorten it. So PRS probes are a useful tool for measuring the soil nutrients. We use them as an alternative for conventional soil testing for over 30 years now in Western Canada. As you can see from all the dots, these are farm fields that we sample. North Dakota in the northern Great Plains, and then a few strategic dots down here in the Pacific Northwest. So just getting started in your region, and thank you, Carol, for giving us the opportunity to talk about this. I will say that we, with Western Ag and the Plant Root Simulator Probe, or PRS probes, always suffered this comparative to conventional soil testing. And there's reasons why we talk about conventional soil testing differently than the PRS technology. And I'll begin at the beginning, as Blake indicated, with the 1992 picture of Dr. Shano. There's Dr. Jeff. Anybody who knows him now knows he has aged a bit, as we all have. But the things that have changed, definitely, Jeff and myself, we've got a lot older. We've still focusing, though, on the Plant Root Simulator technology as a replacement or a better way to assess the soil function. The other thing that's remained the same is the membrane. Still using the same kind of membrane. In this iteration, it was so early that there wasn't even a plastic probe around it. So it's been around for a while, and the focus was definitely dream is a really good way of putting it, because to some people, soil testing is a dream. To other people, it's a nightmare. But it needed some innovation. We knew all the way along that when people thought about soil testing, they were thinking about, well, it's sampling, it's sheets of paper, it's extracts, it's numbers, it's got all of these problems. It's got a number of flaws that we knew about, but we still did it anyhow. And that was the basis in 30 years ago, where we contrasted the conventional soil testing ideas against the better or a more functional approach. Is there a more functional approach to measuring the soil nutrients? And that's where these resin probes came in as a more functional approach. You may want to scan one or two of these QR codes and follow along for more extensive information. This QR code, if you can see it all, we'll give you a link to a presentation, 25 minutes or so, that I gave talking specifically about why conventional soil tests, even though they're flawed, even though we knew it, are still some sort of sacred cow that we can't get around. We have to live with this, all these flaws, where there may be a better way. And the better way that we've been always talking or speaking through is this bioavailable or functional measurement of the soil nutrient supply. So I'm going to hope to play a short video where just zooming into the ion level to see how ions are exchanged back and forth. So we're exchanging ions from the resin, from the resin to the soil solution, and then ions from the soil solution exchanged back onto the resin. So we're capturing a picture of the ions that are available from slow release forms, either clays or organic mineralization of ions. We're going to capture that picture on the resin probe. And that's informative, of course, because as the soil is living, respiring, and growing microbial biomass, breaking down carbon, it's giving off CO2, it's living, and at the same time, you can measure those biological functions in increasing nitrogen supply. So in this example, we kept the soil cold, same water content, warmed the soil up, got more nitrogen supply, about 30% more. When we warm it up even more, we get 5 times more N supply, and we get 10 times more carbon respiration. So we are measuring that soil horsepower, if you will, how much turnover that soil is having, how much nutrient turnover it's having over some incubation time. So this is really important, the difference between how plant root simulators measure the soil nutrients compared to conventional tests. Conventional tests are measuring some extractable amount with a chemistry, some chemical extraction. So dilute acid or dilute base or some fancy water extract. It's always looking at what can be flushed out of the soil as opposed to what can the soil supply. Now, this supply is, of course, impacted not just by temperature, but also by moisture. So if I have soils that are very dry, and FC stands for field capacity, most of you on the call are familiar. But the field capacity is the amount of water that the soil can hold under free drainage with gravity. So 15% field capacity, very dry, up to 100% field capacity, nitrogen supply goes up. If I go past 100% field capacity, I am going to have some anaerobisis, but nutrient supply continues. Same with phosphorus. Phosphorus supply increases from dry soil to wet soil because the nutrients have to diffuse in soil. So the wetter, the better. The warmer, the better. We can think of the soil as an active living organism, and these plant root simulator probes are basically measuring that soil horsepower. So if we measure the soil horsepower, how do we interpret that given all the other things that we have to understand to really predict crop growth? Well, I put this graphic together years ago just to help folks understand what conceptually PRS probes are measuring and why we have to consider some things when we're interpreting that data based on the size of the root surface area. So if I'm measuring nutrients in solution, I'm just pulling those out of solution like the video that we had seen a minute earlier. And as I pull an ion out of solution, the mass balance, if it's a chemical equilibrium, or maybe the mineralization of organic material, is going to replenish those nutrients in solution through all of these processes that are considered generally the soil buffer or the reservoir of nutrients that can be resupply this nutrient intensity or nutrients in solution. So pulling out of solution, if I continue doing that over the first hour, the second, third, fourth, fifth, all the way up to 24 hours, I will have measured not just what's in solution, but some exchange from this slowly available or buffered pools for all ions, so anions and cations. Now, to make sense of all of that, I do have to account for how big the root surface area of the plants are. So I am measuring a standard surface area with the PRS probes, but to make it relative to a crop, I need to know the size of the crop's root surface area, how that's changing over time, how it's exploring, and what that absorptive surface area is predicting, what that absorbing surface area is taking up. So a little bit about the plant root simulator technology for those of you who haven't used it or don't know about it or have seen it for the first time. It has been around for 30 years. So new in relative terms to ag, yes. It's, ag moves pretty slow, but the PRS technology has been used on every continent by thousands of scientists. in hundreds of different institutions. This is my one favorite because, and this isn't photoshopped or AI'd in. These are real PRS probes that were planted in Antarctica along with the penguins to look at nutrient turnover inside or on this soil shelf that's been basically deposited because of ice retreat. And all of this moss that's growing basically is growing in pretty much pure bird poop. And we can measure those fluxes, which is fun and interesting. And there's reasons why people like to read Natasha's blog because it's Antarctica. Not everybody gets to go there. Kind of like Moscow, Idaho. Wait, Blake, you will get to go to Moscow one day, one day soon. So remember that, Dave. We're showing up. But for farmers, a great research tool is only as good as how it can help me. And that was literally where we sat 30 years ago. I sat in that tractor cab, planting my hard red spring wheat and wondering how can this plant root simulator probe measurement, this functional soil dynamometer of nutrients, tell me what to put on fertilizer. So having a functional soil test is great, but if it doesn't tell me how much more or less N to use, how much more or less P to use, under what conditions and what parts of the field, it's really not that useful. And that is likely the unspoken reality of most people's thinking about soil tests. The extraction and the chemistry may be quite fundamentally precise, I will say, but the recommendation system may not be that accurate. And I use those words very specifically because accuracy, in the case of farmers, getting the right fertilizer recommendation for the right crop for the right year, that's a difficult decision, and it's a difficult calculation. Specifically, especially if we use conventional soil testing that's calibrated with field tests. So just for all those who have never been to the Great Plains, there are a few hills. These are some that I actually owned. That's about a 20% slope there, Dave, but it's only on about 150 yards. So not like you have, but it makes the tractor grunt to get up and down those hills. There are hills in the Great Plains. They're just not as intricate as your, wonderful pieces of ground, but there's variability and there's question always when you go across these kinds of landscapes of, do I have the fertilizer recommendation correct? So I'll start with how we use the PRS, the plant root simulator technology, as a replacement to conventional soil tests for the last 30 years. We're going to begin with a soil sample. We're going to try not to dry, grind, crush. We're going to keep as much structure in that soil sample as possible when we put it in a bag. And we're going to add water is the only thing that goes into this bag. Then PRS probes, 2 anion, 2 cation probes. We're going to leave those probes in for 24 hours and absorb the nutrient fluxes over that time. After that, we pull the probes out, we wash them off with water, then we elute with half normal HCl in this case, and then run on standard analytical equipment. So ICP for everything but nitrogen, colorimetry for, so that's standard for nitrate and ammonium. If you wish to learn more about that methodology, you can scan that QR code in the bottom corner and go to a publication that tells you more. So I'll leave it there for a minute in case everybody's fumbling with their QR codes. Okay, moving on. So after we have that data, the what the soil can supply for N and P and K and S, calcium, magnesium, copper, zinc, manganese, iron, boron, we upload that information into this simulation model that we call the PRS, or Plant Root Simulator Cropcaster. So the PRS Cropcaster is a very special simulation tool. We've had it running for over 25 years now, and have used it in many different locations. As you can see, if you're reading, this is from 2015 from the Cook Farm, from some of Dave's plot sites that had different strips of crops grown, and then we sampled. So I'd like to going to switch screens now and run just a little bit of real-time cropcaster scenarios. So we'll share that. Okay. So it may not seem like you're seeing anything different than what you just saw. So the interface is the same. But now we're live and we can play the what if game. So we sampled this south slope. We sampled the hilltop. So this is south slope under canola. We see 60 pounds of N supply, 10 pounds of P supply. K is fine. Need some sulfur if I'm going to grow soft white winter wheat. Okay, how much soft white winter wheat can I grow? Well, this says I can grow 90 bushels. That's 90 bushels if I have a almost full profile of stored water and 3 inches of rain. So that's in-season rainfall. The more in-season rainfall I get, the more yield I'm going to get. That's logical. Now, what's constraining yield in these locations, one of the things that we know of in the Pacific Northwest, has to do with subsurface or lower down compaction, and often root restricting layers or a topsoil restriction. So as I go to the hilltops, which are a lot shallower in topsoil depth and more root restricting, I am going to see a lower yield potential with that same rainfall, because yes, I'm storing less water, but I'm also have less topsoil to store that water in, so less rooting volume. At the same time, of course, I've got less nutrient supplies. So where did my 60 pounds go? Well, the 60 pounds was in the south facing slope. On the hilltops, I'm only seeing 13 pounds of N supply, growing a 58 bushel crop. Go down to the north slope, which is where all the goodness is. The soil is deep. The water is held. The rainfall being the same. And all of a sudden, my soft white winter wheat yields are in that 140 plus. So I know that these are relatively, well, they are accurate yield predictions relative to the slope positions in the Pacific Northwest, because we've worked on this field and seen the yield potential that can be generated on those different slope positions. So are the nutrients changing from site to site? Yes, they are. Is the crop yield potential changing? Yes, it is. So maybe 50 units of N is enough to hit near to maximum yield potential for nitrogen on your upslope. But in your low slope on the north side, 50 units is not going to be anywhere close. You're still going to be leaving quite a bit of yield on the table, even though you have more end supply from the soil. So optimum fertility site by site, situation by situation can be set up. And you can play these what if games. What if I fertilize 100 units, 110 units of N, and um, my 40 units of P? Back that up. And I have to put some sulfur on now. I didn't used to in the past, but now I'm going to go and put my 15 pounds of sulfur on. So this is what I'm going to grow if I get this situation. What if it gets wetter? Well, I'm close to the top, but I can just lock that fertilizer rate and say, play the game of if I get wetter, how much more is on the table. Well, there's 9 bushels more in potential. I'm seeing 140 bushel yield with my current fertilizer blend. I can play and compare those different scenarios by simply recording them to the summary and say, okay, these are the things that, let's go and just get rid of these for a second. Clean that up. So if I go 140, 15, I'll make $790 an acre. This is assuming numbers that I don't know if they're actually very correct exactly for soft white winter wheat, but here we are. We'd be growing just about $800 an acre in net. But if it were that drier situation and the same fertilizer applied, I would only be making $721 an acre. So water makes yield, yield makes money. Yes, it does. If I keep things the same, I'm going to make more money when it gets wetter with the same amount of fertilizer. So the comparative of this system for making not just a nutrient recommendation, but a nutrient recommendation that's specific to the what if conditions that you have. So that's really what we do with the PRS, the Plant Root Simulator technology. It's more than just a different soil test. It's a different soil test combined with a more dynamic decision support system to predict yield outcomes and best fertilizer rates. So I see a whole bunch of chat, which is great. And I know Carol and I are going to go through all of these chats, which is super. At this point, Carol, I think we should open it up for a few of those chats.